I'm Ken Campbell, and here in my shed with all this paraphernalia, I'm going to recreate the experiments which changed the world. This funny donut thing changed the world. It gave us electricity. I wanted to find out how. Hi there. The chemical history of a candle. Yes. Immediately, a sensible effect on needle. I'm going to relive the great donut experiment and tell the story of the man who did it, Michael Faraday, the first working class hero of science. Michael Faraday was born in 1791 near the Elephant and Castle in South London. It was called Newington then, but it was still the wrong side of the tracks. Life was tough for the Faradays. Just before Michael was born, the newly invented steam-driven machines of the Industrial Revolution had put his father, a Yorkshire blacksmith, out of a job. So, like many others, he'd brought the family to London in search of work. Somehow, they eked out a living.
He was a newspaper boy. Then he came to the attention of the local bookbinder who worked and lived in Baker Street, and started helping bind books, which he read.
These are notes Faraday made from the books he helped bind. He was already fascinated by electricity, with strange natural phenomena like lightning and electric fish.
He was a boy of infinite curiosity. I mean, there was a childlike quality about Faraday, wasn't there, all his life?
Electricity was the great mystery of Faraday's youth. What was this strange power that appeared during storms? Even more intriguing to the young bookbinder was some recent news from Italy that would set the course of his life. They had found a new way of making this electric stuff artificially. Here in my garden with Dr. Bryson Gore, I am about to relive the gruesome discovery of the battery.
And a scientist in Italy called Galvani was studying frogs and frogs' legs. And I've got one here. Let's just pop it up. This is a dissected frog's leg. And he was studying the nerves in a frog. And in order to move them around, he had a little wire hook through them. And he noticed that if the frog was sitting like that, and you took another piece of wire and you touched from the top to the leg, there you go. You just have to find it.
Oh, there you got it there. Hi.
There we are.
Yes. Oh. Ah.
And what Galvani felt was that this was almost residual life in the frog that was producing the electricity.
Fortunately for the frog species, someone else realised that the electricity was coming not from the frogs, but from the wires.
You needed two different wires, and this is what was spotted by another scientist called Volta. Now, what Volta went on to show was that really it was the two bits of wire. You didn't need the frog.
Back then, no one understood the chemistry of this. All we knew was that when metals like copper and zinc touch, they produce electricity. And soon we started making batteries. This one's 200 years old and is the one Faraday used in many of his experiments.
Each of those is a piece of copper and a piece of zinc touching together. And here we'd produce 1, 2, 3, about 20, 30 volts, 1 or 2 volts from each pair of plates. This was a revolution. The amount of electricity that these could make flow was thousands, tens of thousands of times more than anyone had been able to do before.
But no one knew what to do with all this flowing electricity. It would have remained a scientific curiosity had it not captured the imagination of Michael Faraday. New scientific discoveries aroused huge public interest in Faraday's day. To find out about them, people came to Albemarle Street near London's West End. This is the Royal Institution, a sort of scientific theatre where the latest breakthroughs were performed on stage in front of a paying audience. If the Royal Institution was a theatre, its star was Sir Humphrey Davy. Brilliant scientist and charismatic showman, his charm was legendary. And his audience was made up of rich women, whose subscriptions paid for much of his research.
Davy's lectures here resonated widely. He talked about mastering nature, about it being useful, about there was a sexy kind of rhetoric of reaching even to the bottom of the sea and penetrating to the bosom of nature. I think there really seemed a hope that with a new industry that was going on, life could really be transformed.
Then one day, by sheer chance, wannabe scientist Michael Faraday got hold of a much-coveted ticket to see the great Davy.
One of the people he was binding books for, one of the customers in the shop, was a member of the Royal Institution here, and therefore had some tickets for the lectures, and he offered Faraday the tickets.
In the spring of 1812, Michael Faraday took his seat in the gods at the Royal Institution's theatre. The rest of the audience, who were mainly from London's elite, were completely unaware of the 21-year-old who sat behind the clock in the middle of the auditorium. They had come to enjoy the show, and that night Davy did not disappoint. What Faraday saw that night bowled him over. Now, more than anything else in the world, he wanted a job as Davy's assistant. He came up with a plan. He would make detailed notes on everything Davy said and did, and use his bookbinding skills to turn them into a beautiful present for Davy.
Burning wire was introduced into the jar of oxygen gas. The combustible brightened up and set fire to the metal, which burnt for a short time in a very brilliant some pieces of zinc, then added to them some diluted sulfuric acid. An effervescence took place, and hydrogen its contents into the fissures. Inflammation immediately took place. Light, heat, and smoke were emitted, and the little volcano vomited forth flames.
He presented them to Davy and said, you know, give us a job. And Davy gave him an interview and said, my advice would be to stick to the bookbinding, that science is a hard taskmaster and it doesn't pay. And Faraday then said, oh, well, but men of science, I'm sure, have such wonderful moral characters and so on. And Davy laughed and said a few years would show him that was wrong as well. But Faraday still persisted, you know, please give me a job. And he seems perhaps to have done some copying out of things then for Davy. But later on, luckily, the assistant here got into a fight with an instrument maker and got fired, and Davy offered the job to Faraday.
At first, Faraday washed bottles and made copies of Davy's notes. It was tough. People treated the working-class Faraday like a servant. But Faraday was determined to serve science, come what may. As well as a burning curiosity, Faraday was inspired by his religion. From childhood, he had been a committed member of an obscure Puritan sect called the Sandemanians. Sandemanians believe every word in the Bible to be literally true, and think the natural world has been created according to God's plan. It was the duty of Faraday the scientist to understand that plan.
He seems to have been really dedicated to finding out about nature. And he gave this a kind of religious significance. God was to be worshipped in Sundays as part of his Sandemanian faith, but was also being worshipped in the laboratory as you found out more about God's works.
This is the laboratory where Faraday assisted the great Davy. At the time, he, and indeed all the great men of European science, were completely baffled by a phenomenon they called electromagnetism. They'd observed strange things happening when they placed a compass needle near a wire. When no electricity flowed through the wire, the needle pointed north as usual. But when they passed an electric current through the wire, the needle twisted. No one could explain why. Then lowly lab assistant Michael Faraday turned his untutored mind to this enigma. In 1819, the 28-year-old Faraday asked his bosses if he could investigate the mysteries of electromagnetism. They indulged him, never guessing that the blacksmith's son would outthink them all.
Faraday is self-taught, so he doesn't have any preconceptions, very bright, clearly, and he's not a mathematician, so he's not going to sit down and try and puzzle out the equations, which are then probably it was a bit premature to do that. Instead, he's sitting there thinking, how does it all work? And what angle can I find on this to do some little experiment to check whether I'm thinking about this the right way? And he really puzzles it out through the experiments and through physical images in his head. And that was a very powerful combination. And for that problem, that was a very fruitful way of going about it.
Faraday's insight was as simple as it was brilliant. Suppose, he said, there is a circular magnetic force coming from the electricity flowing through the wire. That would explain why the needle twisted. The great men of science thought this idea was ridiculous. A circular force? Preposterous! In my shed, Faraday expert Professor Dave Gooding is going to show me how Faraday did his first great experiment to try and prove his doubters wrong. He hung a copper wire above a magnetic rod which was glued to the base of a glass cup. He then filled the cup with mercury, a liquid metal which conducts electricity. If Faraday was right about the circular force, then once an electric current flowed through the wire, it would spin round the magnet. So here we've got the battery, and we've got the current coming through there and into these terminals.
Yeah, and it goes up there into the mercury. That wire goes down into the mercury. It's not attached to anything else, it just goes... It goes into the mercury, and the mercury, liquid metallic conductor. Okay. Right. So it conducts, but the wire can move in it. From the mercury, the current carries on up this wire and down to this terminal here. Okay, this one.
Faraday's still Humphrey Davy's assistant at this time?
At this time, yes, he was. And this was really one of the first pieces of independent research. Yeah. Normally he would make his notes in the diary of the laboratory of the Royal Institution, but these were his own notes in his own notebook, and he was beginning to work more independently of Davy.
So Faraday's scientific career was now at stake. If he was right, if the wire would indeed spin round the magnet, England's scientific toffs would have to accept this uneducated blacksmith's son into their fold.
Away it goes.
Let's see. Here it is, the world's first electric motor, and vindication of Faraday's intuitive understanding of the divine plan. The only clue to how Faraday felt that day are two words in his diary: very satisfactory.
He was very excited because for the first time he'd produced continuous motion, the movement of something, just from electricity and magnetism.
The scientific elite now accepted the South London boy, with one notable exception. Sir Humphrey Davy was jealous of his protégé's success. When a certificate was published nominating Faraday for the Royal Society, Davy was livid.
And he told Faraday he ought to take the certificate down. But Faraday said, I didn't put up, I'm not going to take it down. This is again Faraday's independence. And Faraday was duly elected. But I think one has to see it as a sort of son breaking away from a father. And they never really made it up.
Davy died a few years later. He would never see Faraday's greatest achievements. Faraday knew there was still much to understand about electromagnetism. The wire and the compass needle has shown that electricity produces magnetism. But Faraday and others wanted to see if the opposite were true. Could magnetism produce electricity? This became the holy grail of physics. Immortality beckoned for anyone who could create an electric current, not from a battery, but from a magnet. But every scientist in Europe was stumped by this problem. They held a magnet near a wire, but nothing happened. They held lots of magnets near a wire, but still nothing happened. They replaced permanent magnets with much stronger electromagnets, but there was still no sign of electricity. For 10 years, scientists pursued the theory that if they made the magnetism strong enough, they would get electricity. The theory was wrong, but none of them would abandon it. But not Faraday. He had never adhered to theories. He just observed God's laws, and 23 days before he was 40, all was revealed. August the 29th, 1831, experiments on the production of electricity from magnetism, etc., etc., have had an iron ring made, round, 7/8 of an inch thick, and ring 6 inches in external diameter, wound many coils of copper wire round 1/2, the coils being separated by twine and calico. We'll call this side of the ring A, this side call B. So far Faraday had done nothing new. Coil A was an electromagnet, coil B was just a long wire. Faraday hoped the iron ring would somehow concentrate the magnetism coming from coil A into coil B. Charged a battery of 10 pair of plates, 4 inches square, made the coil on B side one coil and connected its extremities by a copper wire to a magnetic needle, in my case this meter. And now, finally, the mystery of how to get electricity from magnetism was about to be solved. Then connected the ends of one of the pieces on side A with a battery, Immediately, a sensible effect on needle. It oscillated and settled at last in original position. On breaking connection of side A with battery, again a disturbance of the needle. So the magnetism did create electricity, but only at the instant it appeared and at the instant it disappeared. But I admit I was still mystified. Bryson, I've done it. Yeah, but what actually have I done? What's the significance of...
Right, well, I mean, I think the problem that we've got with this is that Faraday had to build everything into such a tight, small space to see any effect with the sort of instruments he had.
This is a modern version of Faraday's experiment. On the left is the electromagnet connected to a battery. On the right is a coil connected to a meter.
What was really important about what Faraday had seen was that it was the changing magnetic field that was producing a current in the second coil. I mean, we can change that by turning the current on and off, or we could use, and Faraday went on to show, that you can use a permanent magnet. If I take this coil away, and you just move that magnet near to the coil, the changing magnetic field is making the current flow around the coil, and that's what the meter's measuring. The meter is measuring the current that flows here. What's making the current flow is the changing magnetic field.
Right, so from this magnet, I am producing electricity.
You are, your Battersea power station. That is how we generate power in most of the big power stations today.
So Faraday had done it. He'd got electricity from magnetism when all the others had failed, blinded by their preconceived ideas. That was Faraday's genius, to tackle nature's mysteries with an open mind. Within a few years of Faraday's discovery, the first telegraph lines were laid. And since then, there's been a never-ending stream of technological wonders that harness electricity. The blacksmith's son had changed the world forever. By the 1840s, the young man who had sat at the back of the theatre during Sir Humphrey Davy's lectures was now more famous than his mentor. Audiences now flocked to see his lectures, and like Davy before him, women swooned before his enormous intellect. Mind you, they drank a lot more port in those days. Here's what one reviewer said.
It was an irresistible eloquence which compelled attention and insisted upon sympathy. There was a gleam in his eyes which no painter could copy and which no poet could describe. Their radiance seemed to send a strange light into the very heart of his congregation. His enthusiasm sometimes carried him to the point of ecstasy when he expatiated on the beauties of nature and when he lifted the veil from her deep mysteries.
The chemical history of a candle.
By his 40s, Michael Faraday had achieved his boyhood dream of becoming a great man of science. He remained true to the lofty principles that had motivated him from the start. He'd gone into science to know the mind of God, not to make money. He never patented anything. Michael Faraday died in 1867, aged 76. I thought I would end my journey where it began, at his birthplace near the Elephant and Castle. I'd heard there was a memorial to him somewhere here. I imagined it would be grand, something befitting a man who was born in poverty and still rose to be one of England's greatest sons. Yes, I imagined the memorial would be very grand indeed. Oh.